Hi, Eduardo. Welcome.
Hi, thank you.
Tell us a few words about you and about the tool.
Yeah, absolutely. So first of all, very excited to be here and to present my tool. So I can actually start sharing my screen. That's going to help me with the presentation. So the tool that I've been working on is called Ploomber. And the idea actually, I think, yeah, here, the GitHub repo. So here we can see the repo. The idea here is that I've been working in data science for 6 years, and one of the most common issues that I have encountered, or I would say difficulties when working with data, especially building data pipelines, is that working on a notebook makes me really productive, right? Because I can enter some code and get some feedback, some charts, and I can code incrementally. I can just figure out the next step and do it. The problem is that as everyone knows, and I think it's something that people discuss very often, is that notebooks have lots of issues, lots of issues, and actually, yeah. So for example, here one of the issues that, and I think that's a pretty good argument, that when you are working with a notebook, and let's say you're using Git or GitHub, if you make a change, then this is what you're going to see as the Git diff, or if you open a pull request, and it becomes a mess. And actually, the difference between this first version and the second one is just a new code cell that has actually just a comment. And it's kind of hard to follow best practices. That's one of the issues. And another problem that I've encountered is that when you start working with notebooks, and especially if it's more than one person, it often happens that people are going to start working in isolation. Like you are going to have one notebook and the other person is going to have another notebook, and then you're going to start sharing data. And this is a terrible practice, because if you share someone a piece of data and you don't know how you got there, and it's really complicated to trace back the results, to ensure reproducibility. So that's the second problem. And now I'm going to talk about the solution, right? How do I think about using Jupyter for maintainable and reproducible pipelines? Because I feel like if we, like the way a lot of people work is they prototype in a notebook and then they refactor everything into Python functions or scripts, and then at the end they take their models to production, or once they clean up the code, they feel more comfortable with the result. And I feel like that's a waste of time, because you are building something, you are tearing it apart, and then putting the different pieces together, which in my experience breaks a lot of things. Like maybe you're not going to be able to reproduce your results, or you're going to get different results, that sort of thing. So the idea of Ploomber is, how do we help people use Jupyter, but still help them follow best practices and fix some of these problems that notebooks have? So one of the first features that we have is, and this is, we actually rely on another library for doing this conversion, is that we allow people to use scripts as notebooks. So you have a script that you can open, it's just a .py file, but you can still interact with it in Jupyter. So we solved this first problem, right? And I'm going to explain how this thing works in the demo. I don't want to spend much time on the slides. The other thing is modularization. So instead of building like the whole pipeline in a single notebook or one or two notebooks, we make it easy for users to build small notebooks or scripts so that they can modularize and collaborate better. So you may have someone who's working on maybe some cleaning transformations, and maybe you are working on some feature engineering. And the fact that you have small files makes it easier to manage, because there's also like clearly defined responsibilities in terms of what this piece of code is supposed to do, as opposed to having a long notebook that does everything from loading data, cleaning, feature engineering, training, which also makes it really hard to test if you're doing all of those things at once. And then related to the previous point is testing. We also help users build pipelines and have these embedded tests. Like if you have a script that cleans some data, you may have some properties that you want to make sure that are there in terms of quality. For example, no NAs, or you may have a categorical variable that may take values A, B, and C. So you want to check that. You want to check that there are no other external different values. And finally, what this allows you, like if you put everything together, it allows you to collaborate and follow best practices. You can do your code, do your work, and then push to your Git repository, and the other person is going to be able to look at the different parts because you have different files, and reproduce your results. And you can even set up this as a continuous integration in a continuous integration system that ensures you that the thing that you are coding, you can orchestrate it and that it runs. Because it's interesting, because I feel like a lot of projects in data science not only don't have many tests or even one test, it's also that you don't even check if it runs, because it's sometimes a bit of extra work to make sure that everything runs smoothly. So that's another thing. Before I start with a demo, I just want to mention a quick few things. We have the repo, so the repo is here. So if you like the project, please show your support with a star on GitHub. We also have a community for people who have questions or just have some comments on the tool. That the community has been immensely helpful for driving the project forward. And finally, 2 weeks ago, we published in the official Jupyter blog, and actually all of these things that I just mentioned are fleshed out in that blog post. So if you want to learn more, some more details, please check that out. Okay, so any comments until here before I start with the demo?
No, please go ahead with the demo.
All right. So I'm gonna do this in 2 parts. The first thing is I'm going to show what's the experience for someone who's just like starting a new project and wants to use Ploomber. And once we have the basic structure, I'm going to move to a pipeline that I coded before to show what's the experience when you fill the gaps and you actually coded the logic. So the first thing is, let's say and I'm in Jupyter. So everything that I'm going to do, I'm gonna do it in Jupyter. So the first thing is I want to create a new project. So I do Ploomber scaffold and empty. Otherwise, it's going to create a basic pipeline, and we want a completely empty project for now. So I'm going to call this, let's call this demo. Okay, so now I have a new folder called demo. So let's start here. This is the central piece of Ploomber, and it's a pipeline YAML file. So this file is the place where we declare the tasks in our pipeline. So following our slides, that would be one node in this graph. So what I have to do is just to think in terms of the steps that I have in my pipeline, and I need to specify 2 things: the input. So where's my source code? In this case, let's say I want to save this in the folder called scripts, and maybe load. So I'm going to load some data. And as you can see, this is a .py file, and this is related to what I mentioned before about using this .py file as a notebook. And I'm going to show that in a minute. The second part is the output. And you might be surprised because we have a Jupyter notebook as an output. And this is an important characteristic of Ploomber. When you use a Python script as a task, when Ploomber runs this task, it's going to turn it into a notebook and then execute it. The reason is that you may have some charts or some tables that you may want to take a look at. And you then, when you execute your pipeline, you can review this file and take a look at all those things. The important part is that when you orchestrate execution, Ploomber is going to run this strictly in sequential order. Because another common issue with notebooks is that you may run things out of order, like cells in different order, and it's going to be a mess if you don't test for that. So when you orchestrate execution, Ploomber is going to complain because it's going to run cells in order, and if anything breaks, it's going to let you know. So that's an important sanity check. So this script is going to generate 2 things. It's going to generate the output notebook, as I mentioned, but it's also going to generate a data set because we are loading data. So we want to output, let's say, let's call this raw.csv. Now we just continue this same logic, and let's say we now want to clean the data, right? Let's call this raw, and then the output from the cleaning step is going to be clean and clean. So same thing, an output notebook and a CSV file. And then finally, maybe we are going to plot some data. So plot, let's call this plot. Yeah, and this is actually going to be, this is not going to have a data file, so just a notebook. So we just change that. And we have the basic structure. Now, if we run Ploomber scaffolding in, instead of creating a new project from scratch, it's going to create all the missing files. Sorry, not there. I need to move to, oops, yes. And then Ploomber scaffolding in. And now it's going to create all the files that I need. So you can see that I have this scripts folder. And now let me show you something. So we already have the basic structure for the pipeline. I have the 3 files, and I'm going to use Ploomber plot to generate the diagram. So now Ploomber recognizes that we have 3 scripts, but this doesn't look like this, right? That's because we haven't specified the dependencies, and that's what we are going to do now. So let me go to clean, and if we are cleaning data, that's because we need raw data as an input. So what we do is, actually, I made that really fast. So you have a Py script here, and then you do a right-click, open with notebook, and this is what happens. Now, if I'm going to clean data, I need the raw data. So let's assume that I already did some coding here, and I already have the logic to load the data. Let's assume that for a second. Now, I want to load my data in the clean script, so I have to edit this special variable called upstream, and I'm going to say, this task depends on load. So this is going to be a list with one single element. And let me reload this to show you what's going to happen now. So if you take a look at this, this is not part of our code. This is something that Ploomber does. What's going on here is that Ploomber fills the missing information. So we are saying in the pipeline YAML file that this is going to be our output. So it puts this information here, so we know where to save our output, because the pipeline is expecting our output to be there. Now, the second part is that we say we are going to use load as an input. And then Ploomber recognizes that and tells me, okay, you told me you want load as an input. This is the location of those output files. So you don't have to hard code any paths. And if you change something here, it's going to change here. And then you can just make references to these variables. So now let's skip to the plot script, and let's do the same. I'm going to say upstream clean. So we just have three tasks, right? Load, clean, and plot. Now that we specify the dependencies, I'm going to show you how the output of Ploomber plot changes. Right, so we now this makes sense now. We load some data, we clean the data, and we generate some results. Now, to show you how you can manipulate your pipeline. So this was just to give an example of how you can start a project and then create the basic files and then declare dependencies, and you have the basic structure for your pipeline. Now I'm going to move to a different folder that has a simple pipeline, but it already has all the code inside of the file, so we can run the pipeline. Because if I run this, it's going to break because it doesn't have anything going on inside. Okay, so let me move to this folder. I'm going to create the plot again to show you the structure of the pipeline. So this pipeline has 1, 2, 3, 4, 5 steps. It's a really simple pipeline. I'm just using the IRIS data set, just getting the data and then generating some features here and here, then joining everything into a single data frame, and then training a model. So as you can see, this is even useful for explaining things to a colleague. Like if you have a pipeline, you can simply use this diagram to explain like a high-level description of what you're building, and that's really helpful to onboard people to a project. That's what I usually do. Now, once you have a pipeline, and actually one important thing about this pipeline is that it also has functions as tasks. Like some people like scripts, notebooks, some other people like functions. In some cases, you may want to use one or another. And the good thing is that Ploomber is flexible enough to allow you to use functions and even SQL scripts, but I'm not going to cover SQL for this demo. So just that small detail. The last task in this pipeline is also similar to what we saw before. It's a script that runs as a notebook. Anyway, once we have our pipeline, we can do lots of things. The first thing that I'm going to show is how do we orchestrate this thing. So I simply have to call Ploomber build, and this is going to execute the pipeline. So we are going to see that first it's getting some data, then it's going to generate some features. This is also for generating features. Then it's going to join everything into a single data frame. Then it's going to train a model. Now, if we are training a model, we are probably interested in some performance metrics. So that's why my last task, sorry, not this one, this file, yeah, has an output notebook. So let's look at that output notebook. So remember, this is an artifact of your pipeline. This is not part of the source code. The source code is the .py file. We can actually hide the code here and use it as a report. So we see this table here. We may even have some charts here that we may want to review. I usually, when I train models, I usually have this output notebook. So if I train, let's say, a neural network and a random forest, I generate the same report for both of them, and then I can just compare one side by side and then take a look at the differences. What else? So we just, another important thing is I just ran the pipeline. And when we are working in data science projects, we usually make small changes because we don't know exactly what's going to work. So we basically run a bunch of experiments. We may try and train a different model. We may add some new features. So it's a really iterative process. And one of the important and most helpful features of Ploomber is the notion of incremental build. So let's see what happens if I call Ploomber build again. So nothing has changed, right? So it's not going to run anything. Now, let's say I want to change my fit.py script. For some reason, let's say I want to print, just to make some small change, I want to print this variable. This could be creating a new chart or even changing the settings for training a model. This can be anything. Now let's call Ploomber build again. Ploomber keeps track of source code changes, and it knows that I changed fit, that I didn't change the other tasks. So it's going to skip all the work that it already has and only run the things that have changed. So this allows you to quickly iterate and avoid having to rerun things that haven't changed. So that's for orchestration. And another important thing that we can do is to run things in the cloud. That takes a bit more time and setup, so I'm not going to show that. But you can export, when you have this pipeline YAML file, you only need a few extra configuration to run this in the cloud. So you can run this in AWS batch, also in Kubernetes, using Argo workflows and Airflow. So it just takes a bit extra work. The important thing is that you don't have to get into the details. Like if you are a data scientist, you only worry about this function does this thing, this notebook does this thing, and don't have to worry about how do I put everything into a container and how do I orchestrate execution. And we have many other features. This is just like the basic explanation of Ploomber. We also, as I mentioned before, we support SQL. And probably another important feature to mention, I'm not going to make the changes in the code because it's going to take some time, is that we can parameterize the pipeline. So for example, here, this pipeline, every time I run the pipeline, generates the outputs in the same place, right? And some of the teams that are already using Ploomber in production are using, and this is an interesting use case, they have some configuration for development and some configuration for production. So for example, they may say, if we are in development, I want to save this in, so we use Jinja to parameterize the pipeline. So they may say, if we are in development, I want to change the folder, right? Or I want to change the S3 bucket, or I want to change the parameters, because we can also pass parameters to the task. So that's also another feature that is really useful when productionizing these pipelines. And that's it. If you like this project, check out the documentation. We have lots of things there. This is taking too long. Anyway, in the documentation, we have user guides, and let's see if I can Okay, yeah, we have a bunch of things, all the things that I just explained, plus some other things like deployments, our support, testing, so many other things. So if you like this, please check that out. And if you have any questions, feel free to reach out. You can find our contact information in the README, and that's it. That's all I have.
Yeah, thanks. I am wondering if you need to add anything to your Jupyter lab, like any extensions, or it just works out of the box?
So once you install Ploomber, it configures the plugin. So you don't have to do anything. The plugin system works really, it's great. So it recognizes when you install a package, it takes the plugin code. If you have some strange Jupyter configuration, it may not work out of the box, but we have some instructions in the documentation, but should work most of the time.
So this feature that you showed, like that you can open a Python script as a notebook, this comes from Ploomber, right?
No, it's from Jupytext.
Ah, okay.
So the conversion between .py and .ipynb comes from Jupytext. But we take that functionality and then add this cell injection thing where you take information from the YAML and add a new cell into the notebook. So we are using their feature for conversion.
Great, thanks. How many people are working on this project?
So right now I've been coding most of it. Now I have a friend who joined, who's also really active. And from the community, we have 4 people who contribute, like small contributions because it takes some time for you to get familiar. But thankfully, we are seeing a lot of enthusiasm from the community, and they are now willing to take more advanced features. So hopefully in the next few weeks, next few months, we are going to get more features faster.
And if somebody wants to contribute, how do they do that?
That's a great question. I would say the first thing is if you want to contribute, run a few examples so you know how it works and what are like the basics. And then go to the issues section on GitHub. And then I have a few good first issue tags. And I think those are a great way to start because I've been tagging those issues so that you don't have to know or understand the entire code base, like isolated parts. And I'm always happy, like if you add some comment in that issue, I'm always happy to help people, maybe give some explanation or some background. We even have some people who just open a pull request. Like they just see the issue, they open a pull request. We just have some comments and then we close it, we merge it. So we are trying to make the process as easy as possible.
Is it a side project for you? Like in addition to your full-time job?
Yes, it's a side project. It's been growing, and I mean that's exciting, right? It takes more time, but I'm pretty happy working on this, especially when I talk to users because they tell me how much this has changed. I would say the most common story are teams that say, yeah, we like notebooks, but our pipelines were a complete mess. And now that we use Ploomber, we kind of streamline working with notebooks and they taking things to production. So I feel like there's notebook users are highly underserved, and most people just say, yeah, just go figure out how to refactor your thing. And I don't think that's the only alternative. So I would say Ploomber wants to provide a different alternative. Some people like it, some people have different opinions, and that's fine. We also want to hear people who may think this is a crazy idea. It helps us to improve things.
Yeah, thanks. What are your plans with the tool?
So right now, I've been, so I would say in the last 2-3 months, I've been putting a lot of work in the community. I feel like there's a lot of value in having a group of people who think this is a good idea and also that can help other users. So I've been presenting at some conferences. I just ran a workshop on Saturday. I would say that's one of the main goals right now, building a community that can support each other.
Do you have any advice to the listeners of this video?
In terms of like open source, or like in terms of
anything you have in mind can be related to what we talked about, can be not.
Yeah, so I would say that if you find some tool, like can be a notebook, can be a library, can be anything. If you find a tool that makes you productive, don't let anyone tell you it's a bad idea. Like, I think the #1 priority for everyone should be optimize for productivity. If a tool makes you happy, makes you productive, stick with it, and maybe find some ways to fix some of these issues. Like, all tools have issues. No single tool is perfect, because it takes a lot of effort to build something that works for everyone. But if you have something that works for you, stick with it. I don't think we should like impose some kind of workflow to someone just because it makes more sense, right? I think we are in data science, we are still at early stages in figuring out how the production workflow should look like. And I think we are going to find several workflows that work for different profiles of people, depending on your background. So I think we have to think in terms of different ways of doing things as opposed to a single way of doing things.
Okay, thank you.
Yeah, thank you.